In this video, I'm going to continue to look at the measure of variations. So let's start with the empirical rule for data with a bell-shaped distribution. So last time we learned about the significantly low value, significantly high values. So if a data is less than or equals the mean population mean minus 2 times the sigma. Sigma is a population a standard deviation. Okay, so sigma low value if the data value is less than or equals mu minus 2 sigma, and or we can say that data value is significantly high value if the data value is greater than or equals mu plus 2 sigma. So now then, the empirical rule says that this for data set having a distribution that is approximate bell shape, it means that the distribution data set follow the normal distributions. Okay, so then the following properties apply. So about 680%, as considered in the figure right here, about 68% of all data values fall within one standard deviation of the mean. So here x bar is the sample mean, right? So the 68% of of all values lies within x bar minus s and the x bar plus s. S is the what simple standard deviation. Okay, and then about 95% of all values fall within two standard deviation, and then about 99.7% of all data values fall within three standard deviations of the mean. Okay, that's the empirical rule. So we can apply empirical rule only if data is what the approximately normal distribution. It means that the graph of the data distribution data is approximately Bayes shape. Okay. Now the coefficient variation is called CV. We're gonna use this one to compare the two standard deviations having different unit. So what that means, by the way, see here, look at the formula. Uh, you're gonna get the problem asking you to find the LCV coefficient of variation. Calculate following that formula. S over X bar. I mean, sample standard deviation divided by sample mean times 1%. So from here we can see that coefficient variation is a percentage. Okay. And now the population CV is also similar to this. So sigma over mu, which is population standard deviation divided by population mean times 100%. So this CV describe I told you the standard deviation relative to the mean. Okay. So now let's see example. Let's see a sample of mean man have a mean weight of 170 pounds with the standard deviation of 25 pounds. So 170 is a sample mean, right? And the 25 is pound is a sample standard deviation of the data set, sample data set. Now then, they have a mean height of 6 to 8 inches with standard deviation of 3 inches. So 6 to 8 inches the a sample mean of the sample data set, and the standard deviation of 3 inches is that's the sample standard deviation. Find and compare the coefficient of variation for man's height and weight. So we want to figure out which the data set um, has the larger the sample standard deviation than the other data set, because the two data set has different has different the sample mean, right? So we cannot so we don't know 25 pounds is the 25 pound is, so that sample standard deviation, I mean that data set has larger sample standard deviation relative to the mean 170 than the 3 inches. That's the sample standard deviation the relative to the sample mean 6 to 8 inches. We cannot say that because we don't know. I mean, so because the two data set has different mean. So in that case, we're gonna find out the CV. Okay. So then for here, 170 for the first data set is 170, right? 170 time divided by, okay, 170, sorry, 25, right? 25 divided by 170, okay, times 100. That's the CV. for the first data set times 100. Okay, so that's going to be percent. The reason that we multiply by 100 because CV, the unit of CV is a percentage. Okay, so that's the weight. Okay, so CV weight. So now then, what about the CV for the height, the data set height? Okay, it's going to be the 3 over 68. Okay, sample standard deviation divided by sample mean times 100. Okay, 100% here. Okay. All right, so we got these numbers 14.705 and the 4.411, but for the uh, the coefficient variation, I mean, when you calculate the variation, standard deviation variance, so normally we round off to the to 1 decimal place. Okay, so we just this. Okay, so CV for the weight is 14.7% and then 4.4%. Okay, so now what can you say about this? So the 14.7%, so it means that what? The first data set about the man's weight, that data set has larger the standard deviation relative to the mean 170. Okay, so now next one is the z-score. What's a z-score? Z-score is just means the number of standard deviations that a given value x above or below the mean. Okay, for example, so in this case, you see back to that example. Okay, 25 pounds. So I mean, so mean the first data set has a sample mean 170 and then standard deviation 25 pounds. Okay, so then we just pick the one data value. Say for example I don't know, maybe just 205 pounds. So I want to figure out that 205 pound, that data value, how much the data value away from the mean. Okay, so that we want to figure out that data value is significantly low or significantly high. Okay, so now then we want to find out, and then we want to measure the distance between the mean and the data value using the standard deviation as a unit. Okay, so that value is going to be z-score. Let me show you how to do it. So sample. Okay, so z-score for the z-score for the sample data set can be calculated by x minus x bar. So x is the data value. What we want to figure out how much that data value is away from the mean as the number of standard deviation. Okay, x bar sample mean and divided by s is the what sample standard deviation. And population for z-score for the population going to be x minus mu over sigma. Okay, so now then let's see. Oh, right here. Let's see example. Man's height have a mean of 68.3 inches with a standard deviation 3. His height is 6 feet 4 inches significantly high, and the 5 feet 4 inches significantly low. So in this case, what we're gonna do, we're gonna find the z-score for those two data values. Okay, 6 feet 4 inches and then 5 feet 4 inches. So 6 feet. Okay, 6 feet 4 inches. First of all, we have to convert the what that the number to the what the unit. We have to convert the unit to the what inch, right? Because 6 feet is what 6 times 1 feet is 12 inches, right? So 6 times 12 plus 4. Okay, so 6 times 12 plus 4 inches, right? So inches, which is the what 72 76, right? 76 inches. Okay, second 76. Yeah, okay. Now, what are you gonna do? And then we're gonna find out the z-score of that data value, 76 inches. So here z-score gonna be x minus x bar which is 76 inches. Let me keep writing inch, okay? The 76 minus, okay, and then x bar, which is 68.3, right? 68.3 divided by the sample standard deviation, which is 3, okay? And then for the next one, give me a second. The what about the 5 feet 4 inches? That's gonna be a second here. That's gonna be 5 times 12 and then plus 4, right? So it's just 64 inches, and G score gonna be what? The 64 minus, oh sorry, 64 minus the 68.3 divided by 3. Okay, so that will give you the number of standard deviations, showing that the what the showing that the number of the standard deviations where the data value is away from the mean. Okay, all right, so I got the 2.56 and the negative 1.43. So it means that what? So the negative 2.56, and that means this 76 inches, that data value is the gradient or equals the sample mean 68.3 plus 2 times the standard deviations. So 76 inches, I mean 6.4 inches, that data value is significantly high. So it's unusual. Okay. And then the second data value, 5.4 inches, which is 64 inches, that's a G score is negative 1.43. It means that in here, it means that see here, the position of the that data value in that number line is right here. Maybe just negative 1.4 right here. Okay. What if we just what about the G score of the mean? 0. Okay. So if you a certain data value has a 0 value as G score, it means that that data value must be mean. Okay, sample mean or population mean. Normally sample mean, because we don't because normally we don't know the population mean. So the why? Because see that x, if x is a sample mean, the sample mean minus sample mean x bar is what's that? 0, right? 0 or whatever, just the standard deviation is 0. So keep in mind this. So keep in mind that, and then see, because by the way, the second data value, the example what we got, which is the this negative 1.43, which is z score of the data value 5p 4 inches right here. So still with that, still within the what sample mean minus 2 sigma and sample mean plus 2 sigma. So that data value is not significantly low value. So it's not unusual. Okay. Now, yeah, so important property of z-score, let's see. A z-score is the number of standard deviations that a given value x is above or below the mean. And the second one, z-score, yeah, the z-score is expressed as a number of numbers with no unit of measurement. So yeah, we normally we don't mention about the unit when you're talking about z-score, okay? The data value is significantly low if its z-score is less than or equal to -2, or the value is significantly high if its z-score is greater than or equal to +2. Okay, keep in mind this. We have yeah, we have shown this one in the last time, right? So now then, if an individual data value is less than the mean, its corresponding z-score is a negative number. Yeah, makes sense. Okay. And then see example comparing the baby's weight and other body temperature. Let's see. So which of the following two data value is more extreme relative to the data set from the which came? I think we have to the what of to figure out the CB, right? Or in this case Z score. Okay. So because let's see. But let's find out CB, because yeah, here they in slide they just they find out the Z score. Okay, so 4,000 gram weight of newborn baby among 400 weights with a sample mean is 3,152 grams, and then sample standard deviation is 693.4. Okay, the second data set 99 degree Fahrenheit at temperature of an adult among 160 others, and then sample mean is 98.20, and then sample standard deviation is 0.62 degree Fahrenheit. So solution, we find the z-score. Okay, so 4,000 gram minus the sample mean, which is 3152, divided by sample standard deviation 693.4. But see, I think the standard deviation is really high. Okay, so what does that mean? Simple set. By the way, uh, the you know s- high sample. I mean, standard deviation. The value standard deviation is high. That means the what the variation of the data is really high. Okay, across the data set. So the anyway, so when you find Z score, we got the 1.22. Still within. I mean, so it means that what that data below 4,000 gram is not significantly high, right? So definitely 4,000 gram is greater than sample mean 3,152. But since the z-score is 1.22, that means 4,000 gram, I mean 3,000, 4,000 gram can be expressed as 3,152, which is sample mean plus 1 times 22 times standard deviations. So the since the 4,000 gram, that one is not greater than y equals the x bar plus 2s, some standard deviation plus 2 times the standard deviation. So that's not significantly high. What about the second data set, 99 degree Fahrenheit body temperature? So we got the 1.29. So still, the within the x bar minus 2s and the x bar plus 2s. So that the 99 degree Fahrenheit, the data value is not the significantly high data value either. So, but since the that data value 99 degree Fahrenheit, each z score is greater than the z score for 4,000 grams. So that means 99 degree Fahrenheit temperature has the what you can say, let me see, more extreme value than 4,000 gram. Yes. Okay. So now the other next one, please read those slides by yourself. I told you the every single the PowerPoint slide, the lecture, the should be in the blackboard. So look at it. Okay. So now next one, a percentile. So what's a percentile? Percentile is this. The uh, the percentile is a percentage of the all of the percentage of the out of the all the data value in the data set where the given those data is the less than the given data. What that means? So for example, so let's find the percentile of this. That one below our test grade for 12 people. You score 81. Find the percentile of your score. So now the you scored 81. Okay, so when you find that, yeah, definitely I'll find that percentile of 81. Okay, because 81 right here, right, in the data set. So then for example, you got the mm, for example 90%. Okay, for example 90% percentile for the 81. It means that 90% of the students, their scores are below your score 81. Okay, that's the meaning of percentile. If you just if you take a SAT test and then you get the the grading sheet, a score sheet, and then you see the percentile, for example, 60% and 80% or 90%, it means that, for example, 80%, it means that 80% students who took the SAT and on the day you took the SAT, the their scores are below your score. Okay, that's the meaning of percentile. So then how can I calculate percentile? See, percentile of I want to figure out the percentile of the value x. Then that can be computed, calculated by like this, that formula. Number of the data values is less than x, and then total number of data value in the times 100. It's easy, right? So where's one? But look at this top one. Number of data values less than x. Then what? You need to sort the data first to figure out all the data value less than the x, right? So, but you can do by using the calculator. So I'll show you. All right, just I added the I entered the all the data value in the calculator. Column the L8. Okay, so now we press the stack button right here. So now you see that here in the under the edit, the number 2 and 3, salt A, salt D. That means salt A means salt ascending order, and the salt D means salt descending order. Okay, let me put the salt A. Okay, and the L8, right? So I'll use L. Second L is right here. Press L, and then 8, and then close parenthesis. Okay. So, oh, give me a second. The reason that I got error because the I entered the data into the column L8, but L8 I mean the initially L8 was not in the calculator. You see that there is only 6 options. We say L1 through the L6 right here. Okay, L1, 2, 3, 4, 5, 6, L6, right? So yeah, so I recommend that you enter the data value into one of the columns, L1 through the L6. But for me, I just entered the data value L8. Then how can you solve the data entered in column L8? I'll show you. So first one is press stack, and then these the choose the salt 8 A in the ascending order, and then press second, and then list. Okay, we have to go to the list. So press second and then list. Then see, so you see the originally there is only L1 through L6, right? But I extended the columns. So there's L8 right here, right? So enter. Then you see um, the subscript L and then capital letter L and A, right? And then close the parenthesis and then click get done. And then if we want to display the data, the column in here, then you just press second, the list, and then there is L8 right here, and then enter. Okay, as you can see that as you can see the data is sorted ascending order, right? Okay. So now then once you solve the data, okay, so then you could figure out that what you can figure out the 81 is actually I mean the number of data value less than 81 must be 9. Okay, so then 9 divided by total number of data value is 12 in this example, and then times 100. Okay, then times 100. Okay, so now then the yeah 9 over 12 times 100, that's going to be, so that's going to be 75. Okay, 75%. Okay, so it means that 75% of students, their score is below the score, your score 81. Okay, now next one, yeah, so you see this lecture slide. So percentiles are measures of location denoted the P1 through P99, which divide the set of data into 100 groups with about 1% of the values in each groups. So you may see that kind of these notation in the online homework. So please be familiar with these notation P1 through P99. It means that percentile. Okay, so for example, what about P99? What does that mean? P99 means that 99% of the uh, the data values are below the data value corresponding to P99. Okay, so then the process of finding the percentile that correspond to a particular data value x is given by the following. So round the result to the nearest whole numbers. Okay, so percentile x value is number of data value x divided by a total number of value times 100. Okay, so keep in mind this: the percentile. I mean the um, the percentile must be the integer. Okay, so please round the whole number. Okay, so now then I think we need to see example. Okay, okay, so airport Verizon. Let's see the example in the lecture slide. So airport Verizon cell phone data speed listed below are arranged in increasing order and define the percentile for the data speed of 11.8 megabps. All right, so first one, you need to solve data, right? So, but luckily, I mean, so data is already sorted. You see that 0.8 through the 77.8. Now, so where's 11.8? So 11.8 is right there. You see that 11.8 right here. So how many data values below the 11.8? See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then there are two columns. There's a 20, right? Two rows. So 20 data values are below 11.8. So percentile of the value 11.8 is 20 over 50. There are 50 data value, right? Times 100, which is 40. So percentile, I mean P sub 40, that's gonna be the percentile of value 11.8. Okay, so now now you see the P sub 40 equals to 11.8, right? And then converting percentile data value. So this is backward. Okay, so percentile is given. We want to find out data value correspond to that percentile. This is a little bit tricky. Listen carefully. So say let's see a notation first. So n excuse me, n means the total number of data value in the data set. The k percentile being used. Okay, so for example, 25th percentile, that means k equals 25. Okay, now L, capital letter L, locator, that gives the position of the value. For example, 12th value in the sorted list, it means that L equals 12. And then PK, K's percentile is a piece of 25, is a 25th percentile. Okay, so look at this one. This one. Okay, so diagram. See, this is how to this is how the process how we convert percentile to a data value. So first one, we sort data, definitely. So arrange the data in order or lowest or I mean ascending order or descending order, either one just fine. And then we compute L locator. It's called locator. Is defined by k over 100 times n. What is k? K is a percentile being used. Okay, it should be given, right? Because we want the problems ask you to find the data value corresponding to percentile. So percentile k must be given. Okay, k over 100 times and n is a total number of data value. Okay, so now then, is L a whole number? Yes. Yeah, then the value of the k's percentile is the midway between the L value and the next value in the sorted set of data. Find the piece of k by adding the L value and the next value and dividing the total by 2. Yeah, so it's complicated, right? I sure don't worry about that. We'll see example in that case. And then what do you know? Then change L by rounding it up to the next larger whole number. Okay, this means a round up. Okay, so now then the value of p sub k is the Lth value, then counting from the lowest. Yes. Okay, see example. Converting percentile data value. So same data value is given in the previous example. Okay, refer to the sorted data speed way below and find the 40th percentile denoted by p sub 40. So now then this sorted data right here. Then we're gonna use first we have to find the locator L, right? So L is what can be obtained by what k over 100 times n, right? What is k percentile? 40 over 100 times how many data value? 50. So 40 over 100 times 50 is 20. It's a whole number, right? You see here. Now you see, yes, this case, yes. L, since L is 20, uses a whole number, and then we proceed to the box located at the right. We now see that the value of the 40th percentile is midway between the L 20th. Okay, 20th. value and the next value in the original set of data, that is the value of 40th percentile, is midway between 20th value and the 21st value. So we're gonna find out 20th value and 21st value in the sorted data set. Okay, so you see 11.6, 11.8, these are 20th and the 21st data value, right? And then we gonna find out it's kind of average of two data value, which is 11.7. Okay, so middle value of two data value, that's gonna be answer. Okay, I mean that's gonna be data value corresponding to 40th percentile, which is 11.7. Okay, so now the next one, quartile, this is the one of the main topic in section 3.3. Okay, so quartile is what, divide data into quarter. So if you think about this, the in in annual, how many quarters in there? So first, second, third, fourth quarter, right? So likewise, we're gonna divide data into four groups: first, second, third, fourth. Okay, but first we gonna sort data set, and then we chop the data set into four groups. Each group is called the first, second, third, fourth. Okay, so now then, the first quartile is the symbol is Q sub 1. Q sub 1 is a P sub 25. It means the 25th percentile. That's first quartile. Okay. And the second quartile is a Q sub 2. P sub fifth. Fifth means the fifth percentile width. So second quartile is nothing but median. Keep in mind this. Remember that when you calculate, when you use calculate to find the standard deviations and then standard deviations, we use a one variable stack. That you get we get the Q sub 1, Q the median, Q sub 2. That's the quartile. Okay. So third quartile is P sub 75 75th. Okay. So there's a 75th percentile. Okay. Interquartile range is called IQR, which is Q3 minus Q1. Okay, which is middle 50%. So now so I told you, see the slide here, the quartiles are measures of location, denoted Q1, Q2, Q3, which divide set of data into four groups with about 25% of value in each groups. Okay, so now then let's see the next one, description of quartiles here. So, question: just as there is not universal agreement on a procedure for finding percentile, there is not universal agreement on a single procedure for calculating quartile, and different technology often yield different result. Yeah. So in this textbook, introduce only one way to define a quartile, but there are a whole bunch of different way. But I'm not going to cover that those things. That's beyond of this subject. Okay. So now the outlier. So now we're gonna clearly define the definition of outlier. So outlier is above Q3 by more than 1.5 times IQR, or below what Q1 by more than 1.5 times IQR. Okay, what's the IQR? Interquartile. Okay, interquartile, which is Q3 minus Q1, middle 50%. Okay, so let's see. First one, yeah, we follow this step to figure out to plot the box plot. The box plot is to represent the quartile, okay, quartile, and then the outliers, okay. So also through the box plot, this is example of box plot. Through the box plot, we can see that where at where most data value is located, okay. So that's the other way to figure out distribution of data, like a histogram. Okay. So now see the a graph of 5 numbers summary minimum. Okay. So minimum Q1, medium Q3, medium is not my Q2. I told you, right? Maximum. So you don't have to do by hand. Okay. You can do this one using calculator. I'll show you. Okay. So let's see example. What is it? Example? Yeah. So you see example right there. So let's find out the Q1, Q2, Q3, and the minimum, maximum, and then let's plot the box plot. Okay. Right. So I entered the data value into the column L9. Okay. So what I'm gonna do? We just go press that. So let's find out the quartiles and the maximum minimums. So we know how to do it already because we're gonna use a one variable stack. Okay, so press stack and then go to the calculate tab and then this choose a number one, select the number one variable stack. Okay, the list it's gonna be L L6 but L8. Okay, so we press second and then go to list and then we choose L8, L9. Sorry, so L9. Okay, L9, and then frequency leave empty, and then press calculate. Okay, so now we got see from one just stack. Well, that one return the most of the basic information about that data set. So 20.7, that's the this sample mean. Okay, and then see that SX, that's the sample standard deviation 8.53, right? So now you see the minimum, and then see minimum value 12, and then Q1 is 15, the median, which is Q2 is 19, and Q3 22.5, and the maximum is 49 right here. Okay, now I want to plot the graph box plot of the data value. Then we go to the stack plot right here, right? So press second, and then press y equals right here. Okay, y equals, right? So now then we choose keep in mind all other plots, plot 2 and plot 3 must be off. Okay, so and then plot, we go to the plot 1, keep in mind is we just on, and then you see that this one. Okay, but we want to plot the modified box plot. Okay, that's a box plot, modified box plot. Okay, so just choose it, the that options, and then we X list must be L9, right? So the L9 plus 9. Okay, the frequency, leave frequency to 1. Okay, and then press zoom. Yeah, so the if you got this, when you just press the zoom and then you got the this kind of options right here, it's okay, don't be frustrated. So then you just go to the press second and then stack block, go to the stack block. Okay, and then press zoom. Okay, and then press 9. Okay, right here. Okay, so now then see, and then press trace, just press trace the key button. Then you see the minimum value, and then Q1, and then median, and then Q3, and then maximum value. Okay, let's see that here. Okay, so when you by the way, so is the if you want to change the maximum minimum, never mind, I'll show you later. Okay, that's too much information. So through the that one, by drawing the box plot using calculator, so you can figure out Q1, Q2, Q3 maximum minimum, or also, and then also using the one variable stack, you could figure out the Q1, Q2, Q3 and minimum maximum, right? Yeah, back to here. So now the please the practice defining Q1, Q2, Q3 maximum minimums using a calculator. Okay, so I strongly recommend that you to look at the lecture slide. You see that example finding 5-number summaries. Okay, and there is the constructing a box plot. Okay, so keep in mind this, and there also the try to solve the review problems. It will help you to understand the practice the chapter 3. Okay, so let me stop here. So next time I'll cover the chapter 4.